Alright, it looks like we're live, so let's get started. So, in case you haven't been here, what I've been working on is a compiler for just a programming language. Don't have too much so far, so we're working on the Lexer right now, which is like the first stage of it. Here's what we have actually. I can put the code in the chat, in case anyone wants to read that. Basically, we have this file, test.un. Yes, and we're just trying to compile this exit system call with a code of 1, or whatever code. We want to be able to handle any code. Yeah, so not too much there yet. So yesterday, we made some progress on the Lexer, and we separated it out into a couple different, into one different file, and clean it up just a little bit. Whoops, let's open .c, main.c, and .h. Yes, okay. So, when we left off, things weren't too great. Let me build it. Unmute. Alright, that's fine. Basically, let me print it. So, for I equals 0, well, tokens I dot type does not equal end of tokens. I think is what it's called. And then we will print token I. There we go. So we'll print it out and I'll show what the problem is right now. Whoops. Tokens I. There we go. Okay. Build /main. Okay, so you can see all the separators are being set to the same value. So I was doing some research, reading through the code and stuff, and I believe I figured out what the problem is. So let's go down here. So here's the while loop, the main one. So when we're setting it, we're allocating space for the token, but not the value, right? So what we need to do is token value equals malloc size of character, and we're gonna have 2 because we have these 2 characters. So if we do that on all 3 of them, because the other ones we are doing that properly in the functions, we just weren't doing it properly with the separators. Now if we build it, there we go. Alright, that fixed the problem. So now basically this is all that we need for the Lexer. So the Lexer for this, the first stages of it, it's working really. And I think we can kind of do some weird stuff. Let me open the test file. We can change this to be any size. Not any size, but yeah, and that works. We can also do stuff like this. And then if we run that, we just get a bunch of semicolons. And that's valid. We're not going to get errors for that. But once we get to the next stage, the parser, it's going to be checking that we don't have something like this that would cause some problem. But yeah, we can put all of these things anywhere like that, and that should still work. Yeah, that's pretty cool, I think, still. But yeah, we don't want that. So we're trying to exit with a code of 1 right now. That's what we're trying to do. I can get rid of some of this debug stuff that I was printing in here. Let's see. Like that. And then I'm going to clean this up a bit before we start working on the Lexer. Free. Also, we can get rid of this, I think. Because I don't think we need to do that anymore. Yep. Alright, that's still working. We just need to, because we're doing that up here when we create the first token. We don't need this. Alright, what else do we have? Okay, this is in the digit one. And I think that's it. There we go. And alright, yes, no. That's in here, no. Why are we getting 2 now? We're reading the exit twice. That's not good. Let's see. Wait, it wasn't doing that before. Yeah. Oh, shoot. This is why we were printing it again. So we were not getting it twice. That was just an error on my part. There we go. Alright. So we still want to print that so we can know what we're working with. Now, I was gonna also clean this up. Instead of using if statements, I'll use a switch statement. So token.type, and let's see, case, whoops, case int token type int, and then we'll just repeat that for all the rest of them. And actually, we need a new line as well. Case, let's see, what's the last separator? And then there is actually one more that I'm going to handle because it's going to give a warning. Okay, and then there's also end of tokens, which we're never going to get here because we don't print this, but still have to handle it anyway. And forgot token type. Alright, there we go. And then we can get rid of this. Okay. So now, got some problem. Whoops. I see what it is. Okay. More problem. Ooh, yes. Break. Don't want it to fall through. And break. Okay. Now, no more errors, and it's all still working. And also, just to make it a bit more clear, I will print that. And then, in here, now we can see sort of where it ends, and it's a bit more clear. Then the last thing I was going to do, just to clean this up a bit more, maybe we'll do some error handling. But also, I was going to do, you can see that all of this is basically just the same thing. So what I'm going to do is, let's see, I'll just sort of move this into a function, right? So let's do, yeah, we're going to token generate separator. And let's see, we want to take we're basically doing the same thing as up here, but with the separators. And also we want to take the, no, we don't need that. Alright, and then I'll just copy this. No, copy this one. And we'll put it here. And we'll also create the token. Token. Actually, equals numeric size of token. Okay. And then I think we can just return token. And now if we go here, the token equals generate separator, and we need to pass in current index, and I think that's it. Pointer, and then I think we can get rid of this, and let's make sure it still works. All right, we have some errors. Semicolon. This needs to be ampersand. Okay. Alright, so it's still working, so we should be able to just do the same thing here. Oops. And also here. And it should still work. Alright, it's working. It looks much better. It's much cleaner and more efficient. I guess this is the same thing also. I'll just leave it for now. So let's see. Got that. I don't know what that means. Let's see. Okay. Now we can do a bit of error handling. So let's do else if current index equals white space, then we'll continue. Else if error unknown character. Let's see. We're not assigning it. Alright, build slash name. Error unknown character. Okay. So if we don't do that, it still works. So it's just like some other characters that are like this, right? There we go. So let's see what it prints. Unknown character. So it has a new line. So that's probably what it is. Alright, let's see now. Now it gets stuck. Huh. Okay. I will not do this. So else we'll just move on. So what happens if we put like a star in here? It just ignores it. That's fine. Whoops. Alright, let's see, errors. We have a lot of stuff going on here. Really quick. Let's do and then we'll just if RC two and then we'll pass RV 0. So now when we try to mess that up. Alright. Okay. Ooh, yeah, we gotta exit too. Okay. Correct syntax is okay. We can get rid of that. /build/mains. Yep. All right, that's good. And then else, which is just all right. Then we will do rv1. Then if file, if not file, file not found. Alright, let's see if this works. Alright, we have that. And if we pass something, file not found. But if we pass test.un, it works. Alright, perfect. So now we have the functioning Lexer. Let's see. Let me kind of clean this up. I was reading through here. So I think instead of doing this, we can rename buffer to current and just use current as that. Even if buffer is more accurate or whatever. Then okay, yes, then it still works and it's a bit nicer. Yeah, current index. Setting the last character to escape. Alright, closing the file there, we can. Alright. This could be better also, but I'm not gonna get into that now. Okay, I'll leave that like that for now. So now we could also do, and then have, should generate 2 tokens, 2 separate ones. Yes. Alright. I'm stalling basically because I have no idea how to implement a parser. So let's just look it up. How do parsers work? A guide to parsing. Parsing. Alright, we don't want human language. Parser. Okay, that's a scripting language. Let's see. Parse tree. Programming language parse tree example. Let's see. Might have to go to Google. Alright, so I think what this basically, when you have expressions, right, it's saying it's going to evaluate this first, and then it's going to go here and evaluate this. Alright, well, let me make the file. So let's do, actually, something else I need to do. I added a new function, and even though we're not calling it outside, I still would like to define it in this file right here. Whoops. There we go. With semicolon. And then that way, just in case. Yes, it still works. Alright, now we will make the file that was on. So Lexer parser f.h parser f.c. Alright, whoops. I want to touch, not touch. There we go. Now we can open it up here. I'll close this one. Parser. And we'll get to the header file after. So alright, I'm just adding some libraries. Let's see. Let's see here. Top down post. Alright, let's see. How do parsers work? Let's go to Google. Code is taken from the preprocessor, broken into smaller pieces, and analyzed so other software can understand. What? New program. Let's see. This is from Wikipedia. Alright, so we're checking if it's syntactically valid. So we're going to be working, let's see, we're going to be working with tokens. So let's actually, I think we can include lexer.lexerfile.h, and then we'll have access to the structs. Which, yes. So then if we do token parser, and we are going to take the array of tokens. So tokens. And then basically we're just going to iterate through them. So let's see. Current token current token equals tokens 0. Well, current token type does not equal end of tokens. Let's just printf 1, 2, 3 with no new line. Alright, now we have to make the header. Alright, and what's the structure? Let's see. H. Okay, then find this. Yeah, parser H, and then we'll just, let's see. I'll just copy this, and then end it. All right, and then should work now, but we have to modify the build file with parser f.c. Now let's try building. Okay. Alright, that is problem. Oh, and we have to, we'll just return. Okay. Now if we go to main.c, and then after all this, we'll call parser. Let me see. Parser tokens. And I think that should work. Not right. Oh, because we didn't include it. Okay. Oh, whoops. Parser f dot. Okay. Whoops. What is it? Test. Okay, and it prints forever. So we never reached the end, because I didn't iterate it. That makes sense. Okay, let's actually print it with new lines, because that'll be easy. And yeah. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Alright, perfect. We got the right amount. So we're reading it properly. So let's think about what we need to do now. So we know, what's this structure? What does the output of a parser look like? Because I knew, like, tokens is the output of a parser, or of a Lexer. Output. Let's see. A tree. AST. Abstract syntax tree. Alright. Statement sequence. Alright, so it looks like, do we evaluate everything on the left first, go down, and then everything on the right after? Let's see. That makes sense. Alright, wall b does not equal 0. So let's think. Alright, so we're comparing this. And we, with the wall loop, we know that we go back and check. And then we go down to the branch. This is each iteration. Then we compare the condition. That a is greater than b. If that's true, then we go here and we do this one. A minus that. We go up here. Alright, so that's what it looks like to me. I'm not sure exactly how to implement that, so let's see. How to sense a tree representation of function. Alright, well, let's think about how we can implement this. So we need node. So type def struct. So if we call this nodes, node. Let's see. So we need, let's actually look at this. Toggle? No. let's see what other people have done to build an example in C. Number, add, multiply. So if you know that's what it is. So would we need a different one for expressions? Lambda. Node represents path. Language statement. So let's move this up here. Alright, let's see. So if we do node statement, and then if we have a node value, the node data. Let's see. And then if we have a let's see. Well, the node data is gonna have a value, and then is there inheritance? C struct inheritance. Let's see. Let's see. Ha ha ha. Alright. Oh, hey. Thanks for following. There we go. It just went through. Hello there, OX29. Very cool. Thank you for following. Okay. What's up? Building a compiler. Working on the parser right now. Which I was working on the Lexer before, and I prepared for that. Didn't prepare for building parser at all. So, kind of just trying to figuring it out. Variable, condition, statement. Alright, so all we have right now is values, and then one statement, which is what we need to evaluate. Okay, so that's how you make like a regular tree, right? And then you usually get some value. So let's kind of try to do that. So let's just make a node root equals node. Root dot length equals. Let's make 3 nodes there. Node root equals that. Or nope, that's not right. Left. There we go. That's what I wanted to do. And then right. equals left, root dot right equals right. And let's just make a quick function to print tree, and we'll just take node root. And then, let's see, node current equals root, and then printf, let's see, printf root 1, since there's no values, root 1. We'll just do that. And then current equals root dot left tree dot right. Actually, I don't know if we need the current. We'll do if root equals null, then return. So let me just see what this output is. Problem. Oh yeah. Alright, let's try running this now. Alright, now let's try this. Alright, no, that's not right. Assignment. Alright, there we go. Now it still won't work. That's a problem. Alright, let's try that now. No. Alright, I will just get rid of that for now. Oh shoot, actually, let me see. And semicolon. Oh yes. All right. All right, and it broke. Actually, let's set this to no. Alright, there. Now we can check if it's no. Whoops. Okay. Root 1. Let's see. Let me get rid of this print statement. Oh, I didn't put it in new line. Alright, do you even Lex, bro? No. Well, yes, I did a Lexer. Kinda. Yeah, basically what I have a Lexer which can basically tokenize this, right? Basically what you can see creates a token. I'm not sure if I'm doing it right. I don't really know what I'm doing, but just learning, you know? So value of exit, a type of keyword, and then value of separator, which is the parentheses, and then the integer value, and we can set that to be something like that, and it still will work. You can see, yeah. So now I'm working on the parser. Okay, so there we go. Now we are printing that, and let's actually give it a value for test. To test it. Value equals 1. Dot value equals 2. Then right value equals 3. Nice. Nice indeed. Let's see. Now should be able to. Alright, now we can print the value. So this will be the structure of it. I think it'll be something like this, but so can the value, let's see, the value will probably be a list of like enumerators, like that what we have here. But that wouldn't work if it's a literal, like an integer, like how we have. Where did I put it? Yeah, I closed it. Basically the one that we're trying to exit. So I need to handle that, which would be an integer. Let's see. I'll get rid of the. Just have the 1. Okay. Oops, highlighted it. So let's see. And then we want to also check the syntax to make sure, like for example, I'll open up the test file. We don't want it to be something like that. That would be a problem because we have a closed parentheses without the open parentheses. So I think we can do that with like a stack, where when you go into the open parentheses, it's pushed onto the stack, and then when you get to this, when you pop the stack, it should be an open parentheses. If we use, yeah, I think that would work. And then use that along with the tree. So let's see. So the value, it'll probably be, we'll do a value like that for now. And then, I guess what we can do, so we'll want to create something to initialize the nodes, right? So we'll just do node initialize init node, and we'll take a node, and then let's see. So well, we want to do what we did here. So we'll do node node, and then we also want node.left equals null, right equals null, and we want to set node value equals, we'll do 1 2 3, but we'll want to pass it like, get rid of this, and we will return node, which I don't think we even have to return the node, but now we can get rid of this, all of these, and we'll do node root equals, actually we'll do node root, and then init node root. Alright, and let's see. Alright, actually if we, alright, unused, that's okay. There's no errors though, right? Oh yeah, I messed up the print function, that's okay. Slash, whoops. Okay, so I'm assuming it worked, but I guess I shouldn't really assume it. Let's actually do root equals slash, and then we'll print tree root, and I will change this also. We'll get rid of that. Let me see. Well, let's see. Node value I equal exit, then we will and then we'll put a new line. So now, alright, now it should work. And it did not work. So I probably messed up something really obvious, but we will see. So I'm assuming it goes before here. I mean after. No. Okay. So it's a problem with this. No, it's not a problem with that. let's see. Alright, that's weird. Right, that could have been a problem. No. That probably helped them to do that. Let's see. And whoops, I gotta set this to left and right. Equals null. Alright, so the problem is within this function with this. If I get rid of this, it does work. So it's the problem with that. So this must not work. Oh, I have to do, no, that's not right. Alright, that's not right. Let me go into here. Let's see. Okay, so my Wi-Fi went out, but I'm back now. So I managed to fix what was going on. So let's see, where were we at? Alright, basically what we're doing now, so we're initializing each one of the nodes, and we're passing in a value of a string, right? And then we're setting the left and right by default equal to null. And then in here, the problem, it was that, well, we were looking at the next one, and it wasn't assigned. So that's all working now. So if I run this, oops, there we go. If I run it, you can see it prints out these values. So we initialize them, and then it stops once it gets to a null value. Yes. And then here, I just set it equal to those nodes. But we can make this say, actually, I think we want to do right before left. Because, no, I want to do left before right. Yeah, that's what we want to do. That is what we want. Okay. So this can have any sort of value, basically. So we could have, let's see, exit is the value. 1 could be the value. And then also it needs, like, some like an identifier of sorts, which we'll get there. We will get there. And then this can also be a semicolon, right? And then we print them all out, exit 1 and semicolon. Which I don't know if we need values for semi. Well, yeah, we do, to check the syntax. Right. Okay. So we need and these will be the I guess it's types, right? Node types. So each node has to have a type. So they can be like integer, literal. There can be statement, or is exit a state? Is exit a state? I'm not sure what the correct term is. Exit statement. Alright. Sounds good to me. So statement, exit, and then there can be also just like separators, just like we have in the other file. That's all we need now. So then there also is going to be node types type. And then we have to set the type in here. Node types type. And we'll just do node type equals type. And so we'll pass, so this would be statement. Here would be integer literal. Can't type at all. And this is like a separator. And then, okay. So I think I'm messing up in here. This is a problem. Okay, there's more problem. Oh, it's because I typed out little. Alright. Spelled that wrong. I just completely messed this up. State. Okay. Oh, okay. That's the problem. Supposed to use commas in structs. Alright, that fixed a lot of problem. Do you mean print token? No. And that is a problem also. Okay, almost done. From enum to node types. Right. Oh shoot. Alright, this needs to be called something different because it's the same as in our Lexers file. So this will be, wait, no, it's not the same. Separator. Alright, well, I still want to change it anyway because that's going to get confusing. So what else could a separator be called? Like a, let's see. Okay, let's just think of what would work. Maybe like extras. We'll call it that. I don't really like it. I will probably change it, but then it should work. Plus. Okay. Yes. Alright, so now I think we can basically use this to create a tree. So if we have the root, we want to initialize it with like a value of program or something like that, right? Statement sequence. Well, we'll just do program. Okay. And then we'll do, maybe we can call this like begin, something like that. And then we'll know that's the root node. And then each one of those nodes will create within the while loop. Let's see. Trying to think about how I do this. So we're going through and we want to change the root node, right? And we need to figure out which one goes left, which one goes right, based on priority. Let's see. So let's kind of think about how it would look. Let's open Paint. Alright. That is very bright. It's not good. How do I don't use it very much, so I don't know. That's not right either. No. How do I change the size? Decrease brush size D. I don't really want that. I want like a pen. Alright, that's not right either. I'll just do it with this. Alright. So we have our root node. I can't draw it all when I just have a mouse. So this is like the begin. It actually looks not too bad. Alright, and then we have the left and right. So on the right, that's going to be the last thing executed. So that's where we'll put the exit, and then want it to have just like a value. So 1. Then we'll go here. We'll see, oh, it's an exit. So we'll look to the left and do it with that. And then, so like you can imagine over here, let's see what we would, and here, yeah, we don't need anything, but then we also need to account for the separators. So maybe it would look a little something like, so this is like the semicolon, right? I'm just winging it here, by the way. And then let's see, eraser. That's not what I wanted to do. No. No. I wanted to do yet. Is this not an eraser? Can I just do that? No. Alright. Let's just kind of change this. Now, okay, I see how it works now. Alright, that's good. Okay. So we have like open parentheses. And then the last thing we're going to execute is the close parentheses. And then we're going to look at what's inside of it. So it's going to be a 1. But it could be something that branches off like 1, 2, and then this is a plus, right? And then we would evaluate it. We look over here, alright, we have 1, then we look to the right and there's a 2. And you could see how we could discuss, or we could basically check the syntax with this, right? If we have a plus and we look to the left, there's a node there. We're like, alright, let's look to the right, there's no node. That's going to be an error, so we'll return an error, right? And same thing with this. We look to the left and that's all fine and dandy. But then when we look to the right, there's no close, so then we're like, uh-oh, and then there's an error. But if there is, then we can get all the way back to the exit. This is a semicolon on an I. All the way back to the exit, and then we just do the exit. And the semicolon doesn't really matter for the last one. But yeah. And then you could look over here, and we'll just say we have like an if, and then, or well, maybe we could say something more like condition. Condition. And then we have, we'll say greater than. Then we go over here, x greater than 2. And now x isn't defined here, but if we had defined it before, like this is going to be, like imagine we go here, and then we do equals, and if it's a single equals, that's defining it, and then, actually, equals, x equals 3. I think it'd be something like that, right? You can imagine that, and pretend, then, well, I guess, yeah, and then this would also, like, this would be the leftmost one. So I guess it could have more nodes than one node. Like, based off this, see, something like this has more than one. So I need to figure that out. But yeah, so we go back here. This is equal. So x equals 3, I think is what I put. And then we go back here. Condition greater than, x is greater than 2. That is valid. So then we can go back here, and then we can perform the exit. Yes. Alright, so that, I think that kind of makes sense. So we need to basically figure out how to order it, and how to figure out, how to order it, figure out which way it goes, and how to have more than one node, or more than 2. Because right now we have the left and the right, but we need more than that, because we can't just break off at this one. So that's basically what we are looking at here. So I think we can kind of just use the right here for this, just for demonstration purposes. So we do something like, no, that's not what we want to do. If we check if root, let's make a current node current equals root. I don't know if we have to allocate. If current equals root, then let's bring root, and we'll do stuff there, and then current, and here we can set current equals the current left, and we go left first because that's what we evaluate first. But then we also need to get back to the root, so I need to figure that out. And we don't always want to go to the left, like, so if we do like if current left equals null, and we'll do current equals current right. And also we should check if that equals null as well, but current equals current right. Okay. And then, so we're in the root, and then we, let's see what this does. Alright, it creates some issues. Okay. That is not equal null. Else if that length equals null, not equal null, dot right. No, does equal null. No, we don't even need to check that. And then else break. Alright, yeah, so we are not sure what we're printing there. Oh, okay. So we never initialized these nodes, so that's the problem with that. That's what all that syntax is about. Yes, unused, that's okay. We don't actually need these here anymore. Well, yeah. Else break. Alright, so I think it's breaking after one iteration, and we can verify that by doing it. And then, because it should be null on both of them. Yes, alright. So if it was not null, so actually we do need left. I don't think I need to do that actually. Alright, let's see, that should still work. Alright, but it still is upset, so. And then left. Alright, let's see. Actually, I think if we just do that for both of them. Alright, oh yes, and we need to set this. So root left equals left, right equals right. Alright, now, and alright, okay. Let's actually give these a value, J and K, which are not integers, but that's alright. J and K, alright. So we are printing those. And I'm assuming this is working. So this can also, we can get rid of this. Make node. Alright, and then, there we go. So now, it is uninitialized. But it does get initialized, so I don't understand. I'll just ignore that. Okay. Current equals root. Okay. So now, and right. So it should go right once, or it should go left and then right. Went left. Alright, it went left and then, oh shoot, it stopped. Because we aren't setting it back. Okay. Let's see. So we want to set it, the current node, to root right. No. It's just called current. Current, whoops, equals root. Right, and then we never break out. So let's do if root equals, or if current equals null. Null, then we will break. And that should fix it all. Okay. Root and then went left. Then put a new one. So it's still alright. Current left equals null and right does not equal null. Else current equals. Okay. So the problem is that we go right and then never print it. Let's see. So I need to figure out sort of how we're gonna, let's like that. Let's actually kind of restructure this because I want left to be first because that makes it less confusing. Current dot left not equal null. Then current equals current left. F1 left. Okay. And then else if current dot, well, no, we don't even need to check that. Current dot right does not equal null, and when right, and then current equals current right, and then else current equals root. But then we need to also set it to null so that we can go back, like basically remove it from the tree. So we should probably make a function that removes it from the tree. Let's see, this is probably gonna run forever. Yeah, no, it didn't run forever. No, because it got to the end. Yes. If I set this to be root though, then it'll just go forever because it keeps going left. Oh, I guess it didn't go forever. That's okay, interesting. I wonder if C caught it or if it's, oh shoot, it's because of this other condition that we have. Okay, that makes sense. I guess we're kind of doing two things here that we don't want to be doing, because we're iterating through this and we're checking if current equals null. So when I start at root, I want to first assign to the left, whatever we get. And then at the end, once we reach an exit statement, we can just place something right. So let's kind of do that. So if current token type equals, what is it called? Let me see what I named it in here. Keyword. I'm just gonna, this is gonna be pretty rough, but, and current token dot value equals exit, then root dot left, root dot right equals, let's make a new node actually, node exit node equals init node. And let's see. Why are we just passing? Oh, shoot, that's the problem. Init node. I don't know if that works actually. Oh shoot, that's what the problem is. Alright. Yes, I just figured something out. So I'm gonna get a lot of errors, actually. But that's okay. I'll work through it. Let's see. Exit node exit and statement. State. Yes. Alright, equals exit node. Alright, and let's see. Equals. Okay. Yeah, that's what I was talking about. Alright, one forever. Exit node. And then we'll break. And we'll also put that exit. Okay. Now, build. Okay. Here's the problem, because no, that's not the problem. Alright, well, let me fix these errors. So let's do node root malloc size of token. Size of node, not token. Node. Left and right. And then here, you can just check that. And the same thing here. So node equals malloc size of node. And we can get rid of this. Alright, now ooh, okay. The problem is that we need to compare it like this. I forgot. That's how C be. Okay. Did I not include string.h? Oh, I put strings.h. Well, that's the problem. Okay, and now we got an exit. Let's go. Alright. Because that's the first one. So we set exit to that. And then we want to go to the next character. Maybe this would be better as alright, well, let's see. So the next character should be an open parentheses. So we can just set, yeah. Alright, well, we can, let's see. We can actually get rid of this stuff right now. Hang on. Okay. Back down here, yeah, I'm just checking this twice because I didn't actually delete it. Alright, so we can not that. We can just get rid of those. Actually, there we go. Alright, save this. And it should run still. Alright. Now we want to set the left to be the next character. And then set the current to the left. Alright, so let's do actually this probably isn't the right way to do it, but let's do current equals root right. And then we're gonna do current left equals, actually we'll do current token equals current token. That's not right though. Left value equals current token. Yes, and this can be actually current token value. That will run into value. Alright, and that should still run. and then it breaks. Okay, because the value, well, hang on, current equals root.right, or root right, and then current token plus plus. Exit node. Right. Exit node. Oh shoot. So the problem seems to be that the left is not a node. So node, new node equals numeric side of node, and then new node equals, let's see, exit node, no, new node, current token value, and what did I call this again? Extras, okay. Extras. Alright, yes, extra. So now, left equals new node, which actually let's rename new node to what's supposed to be open parent node. Nodal. Open parent node. Alright, and now it should be. Yes, let's go. Alright, now we need to do the same thing for the value within there. So the thing about the value is we're not handling this yet, but it could be an expression or a variable or something like that. For now we'll just handle it as an integer, but we need to keep that in mind for the future. So expression node current token value and int. So we could probably check to see if it's alphanumeric, or if it's alpha. If it's numeric, that's what I'm trying to say. Then we'll see if it's a float or an integer. And if it's not numeric, then we'll see if it's a proper variable. But we're not doing that yet. So equals, how did I lay this out? Let's see. So yeah, and then equals, let's see, extra node. Now we're doing current dot left dot right. Alright, yes. Node close paren node equals malloc size of node. Close paren node equals init. Value, and this is another extra. Let's call it, let's change it all extras. Yeah. Do extra. There we go. Alright, now, because that's a bit nicer. And then, let's see. Left, right, equal, not that way, equals close. No? And then, let's kind of separate this so it's a bit easier to read. Okay. No, that's not what I wanted. Okay. Extra. Alright, so we have the open parentheses node, expression node, close parentheses node, and then we can go all the way back to the current, and we can set the, so this is going to be the semicolon. So node, semi node, equals malloc size of node. Semi node equals init node. And we could separate this out into a function as well, but not doing that now. Extra, and let's see. This is another extra, yes. Then there should be no more current token. So we should actually still need to set this. Current right equals semi node. And then all the nodes should be complete. Alright, so that runs. So now we kind of want to just print the tree. Tree root. And it might break. Okay. Let's kind of, let's see. Let's set an index. How's that? Maybe that won't work. Alright, well let's see. So we have the root, and we're printing it. Alright, this is just going right, and then it should go left. Program. What is, oh, okay. Here is actually where we're at. So this is printing the other characters. Oh shoot. Alright, it's because we are initializing it with J. I think I can get rid of that. Alright, yes. So then it's a bit better. Alright, so program, that's the root node. We're printing that we're at the root. We don't need to do that. But we do want to keep this, so we'll continue. I think continue is the right thing. Okay. No, continue is not the right thing. Alright. Okay. So we have the program, that's the main one. To the right of it, let me draw this. Program. I'll call it P. And we don't have anything to the left. So it's empty. And then to the right, we have got exit. Exit. And then let's see. Then we print the left. And we have the open parentheses. And then the left again. And we have the 1. And then we go back here, and we have the close parentheses. Then we go back here, and back up here, and we have the semicolon. Semicolon's weird to draw. Alright, semicolon. Okay, so basically, yeah, this is the main program, the root node. We go to the right, because it's exit. So we'll just, for now, I guess we could check if it's exit, and then always go to the right from the root. Whenever we reach the exit, because you're not going to do anything after exit. And then we go to the left. So then basically what we have to do now is we need to check if it's exit, and then we need to make sure the left of that is an open parentheses, and we need to make sure the left of that is an integer or an expression that equals an integer, and then we need to make sure that to the right of it is a closed parentheses, and then we need to make sure to the right of exit is a semicolon, because that indicates the end of the line. So I think, so that's our tree. So now, yeah, I'm pretty sure, so I will actually commit this. I should have committed it before, but alright. Lexer working for test file. Started on Parser. Have a tree. Implemented a tree. Needs further work to actually parse. Alright, I will go ahead. Alright, so I pushed that. So now, if I share the link again, I'm not sure if it stays. There's the link. If you want to check it out, if anyone wants to. Yes, so that should have updated. There we go. Alright. So, yeah. So that's going to be the end of today. Next time, I'm going to do some research in between. Probably clean a few things up. I'm not going to actually implement anything. But I'll clean some things up, maybe add a couple comments, make it look nice. And I'll do some research, figure out how a parser is actually supposed to work, and then we can fix it up from there and try to get something working where it actually parses it and then checks to make sure it's correct. And then after that, we can work on the code generator and start generating some assembly. Yes. Alright, so that's it. Thanks for watching. See you next time.